Hey all you cool cats and kittens, this is Shetz, and today we're going to take a look at notes on 8.6 applications of law of sines. So it says that Nathan lives 200 feet downriver. Well, obviously then the river must be going that way. And from Joe, there you go. And Nathan's view of the other two houses is an angle of 100 degrees. And I'll try to make this video as short as I can, but we do have 6 examples to go through. And it says that Joe sees the houses at an angle of 38 degrees. Okay, and they're asked to find the distance between Nathan and Amy's house, so that would be that X right there. Well, with a little bit of math, we have these two add up to 138. That leaves this leftover angle where Amy's at, 42 degrees. And we can simply use the law of sines. 200 is across from 42, and X is across from 38. Whoops, sorry about that. And we're going to use this law of sines equation. When you cross multiply, you get X equals 217.37 feet, and I believe that one was rounded up. Okay, now we're on to the second problem, and here we have 2 tracking stations and a satellite. It says that the satellite, tracking stations are 50 miles apart, and the one angle, station A, we can see an angle of elevation of 42 degrees, and the other station has an angle of 65 degrees of angle of elevation. And what we're asked to find is how far is the satellite from station A, and I'll call this guy A. Well, we can, whoops, did that again. And notice that this is across from that. So what we have to do is find out what this angle is, add these two angles up, subtract from 180, and notice we are going to get 73 degrees. So I do my setup law of sines, cross multiply, and X turns out to be 47.39 miles. And that also was rounded up to the second decimal place. Continuing on with example 3. Hey folks, this one is super duper important. It is quite involved. And in your homework, you're going to do this about 4 times. So please replay this section of the video 4 and 5 times until you actually get it. So let's take a look at it. Boat sites say lighthouse, 18 degrees. There you go. Now, as the boat travels to the right, to the east, after sailing 1,000 yards, it gets a second sighting. And I kind of did this example in the classroom, but you probably forgot about it. It gets another angle of elevation of 62 degrees. Right there. So obviously when you move closer to an object, the angle is going to be greater. How far above the sea level is the lighthouse? Well, there you go. We want to know what this orange Y is. We want to know that distance there. Well, as I told you, this problem is a little bit involved. And I would really like to do SOHCAHTOA, but I only have one angle in this small triangle. And again, I only have one angle in this big triangle, and I only have a piece of the adjacent side. So different ways you can do this, but I will hold that off for now. And let's see, we got to find either this side, this hypotenuse, or this little hypotenuse. Well, I know this is 62 degrees, and I also know that this makes a straight angle, which is 180. So the supplement of 62 would be 118. That's great. And now this is a triangle here, and I can find this small angle up there. Well, when you subtract those two angles from 180, that becomes 44 degrees. All right, that's great. And if I could find out, I'm going to go after this piece instead of this one. I can use the law of sines. X over the sine of 118, 44 over the sine of, 1,000 over the sine of 44. Wow, I almost screwed up there. Well, when you cross multiply, guess what you get? You get x equals 1271. And that would be this side over here. Now, I can go back to this and use SOHCAHTOA. Here's my hypotenuse. I need to find the opposite side, so guess what trig function that's going to be? That's going to be the sine. Sine of 18 degrees is this opposite over this hypotenuse, and when you this is a type 1, and when you multiply both sides by 1271, you get 392. There you go, folks. Study this problem, and it's going to crop up about 4 more times. Now we move over onto the next page, and now we have applications using law of cosines this time. Well, here we have a tunnel being built through a mountain, and we know one side of it from the guy is, end of the tunnel is 388, and the other side of the mountain, the end of the tunnel, is 212. And we know that the angle between the two is 82 degrees. Whoops, did that a third time. Strike 3, shuts us out. He better go watch his Eagle cams and relax a little. So this angle is 82 degrees, and this is the easiest type of problem when we do law of cosines. We do have side angle side, and we can go right after that by using our formula and plugging it into the calculator all in one step. Bada bing, bada boom, we now have 415.44 feet. And I believe that stayed rounded down. And our next problem is an example when I taught down in Chesapeake City, Maryland at the C&D Canal, where you would see tugboats. So let's go over this. These tugboats are one tugboat, they're 80 feet apart. So these are your two boats out here, and they're pulling this barge. And we know that one length of the cable is 130, the other one is 110. And what they want to know is the angle that's between these two. They want to know what theta is. But wait a second, this is side, 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 and we were taught that we always have to go after the largest angle. So if this is the biggest side, we know that this has to be the biggest angle. So folks, we have a lot of math to do. This is the harder type of LOC, where I told you I wanted to see all the algebraic work. So we got some work to do. Here's my setup right there. And when I square 130, I get 16,900. These two squared will give us 1850, and then minus that. Now remember what I taught you. These two are close together, but guess what? They're unlike terms. So do not subtract them. We're going to subtract this 18,500 and put it on this side. And notice what we're going to get. We're going to get a negative 1,600. Now we divide by 17,600 negative, and we're going to get this decimal of a 0.0909. I think that kept repeating when I did the work. And when we arc cosine that, because we're finding an angle, you do get an 84.78. So that means that this beta down here is an 84.78 down there. Now we can use the law of sines, and I'll just put that one right there. That's a little nicer. Now I can use law of sines. 130 is across from 84. 80 is across from theta. and we will use the law of sines. And when we arc sine it, cross multiply and arc sine it, then we get a 37.79. So that's the answer to example 2. And that's what I love about math. Given a real life problem like this, we could actually find that angle. All right, folks, we go down to example 3, last one. And again, here's a surveyor standing between a lake. So let me quickly draw the lake here. Here's my lake. Looks like one of those lakes up in Canada. Great fishing in Canada. So one end is 3 miles, the other end is 4 miles, and there's the guy standing there. And the angle between them is 53 degrees. Again, we're trying to find out how wide this lake is. And this is the first example I've ever done with LOC. And that immediately, everything gets plugged into the calculator. And we get a 3.25 miles. So there you go, folks. I'm sorry this was a little long, but I'll give you in the notes what your homework's going to be. It will be 8.6a, and that'll be the next 2 pages. All right, folks, take care, and keep watching those eagles. They're pretty amazing, I'll tell you that. Let me see if I can quickly find them. Here they are, and there's that stuffed animal right there. Thanks, folks. Take care.